Hello again, everyone, and welcome back to WoodChat, a Forest and Wood Products Australia podcast. I'm Georgia.
And I'm Sam. Now, you may recall in episode 23 of WoodChat that we looked at a number of ways Australian researchers and foresters have been harnessing the latest technologies within the forest to enable smarter forest management.
In today's episode, we're looking to the next stage by considering some of the initiatives being implemented on the wood processing side aimed at creating a culture of smart manufacturing.
That's right. You'll hear from representatives of a couple of Australian forest and wood products companies that are thriving thanks to the adoption of smart manufacturing principles for the benefit of industry profitability and safety, and for the environment more generally.
Manufacturing company Timberlink has long been committed to continually optimising its processes while looking to future industry trends at its Bell Bay, Tasmania and Tarpeena, South Australia sites.
I caught up with Timberlink Technical and Sustainability General Manager Trevor Innes to find out more about some of the organisation's recent upgrades. But first, I wanted to see the upgraded equipment in action. Hi Trevor, so good to meet you. Thank you so much for agreeing to show me around the Tarpeena site.
No problem. If you'd like to follow me, I'll give you the tour so you can get a proper look at some of our new and upgraded equipment, which should give you a good sense of the improvements that are being made here.
Walking around this site, it's incredible to see just how much goes into the processing of the timber that finds its way here. And seeing all of this highly sophisticated technology in action is fascinating.
We're a major pine sawmiller principally, so we've got two large sawmills, one at Bell Bay in northern Tasmania and one at Tarpeena in South Australia, probably cutting about 1 million tonnes a year of logs at the moment.
I guess the first thing that I wanted to just get a sense of was the Tarpeena site. And I know that there have been some kind of specific sort of upgrades recently to some of the technology that's used. I was wondering if you could maybe just give me a little bit of an overview of what's been happening there.
So we've increased the kiln capacity there a couple of times. We now run a couple of very large continuous drying kilns. So these are contraflow type kilns. They're about 30% more energy efficient than a traditional batch kiln. We've previously done upgrades in the dry mill. That was a couple of years ago, updating the grading systems. And we've just finishing off a project now, put in a whole new saw line. The old saw line was you can think of it as being sort of fixed saws. So logs were sorted into quite narrow diameter classes, and then each log would go through exactly the same cutting pattern. We've added a new line there now, and that's a scan and set line. It's got additional technology that scans each log and sets the tooling around that log to get the maximum recovery of the products that we want to manufacture out of it.
And what motivated those upgrades? Is it just a case of continuous improvement, or was there a specific driver for implementing some of those changes?
It was a range of things. So the existing infrastructure was unable to process the amount of additional log that was available to us. And in addition to that, the existing assets were getting a bit aged. So with a pretty significant capital investment, we can put in newer sawing technology that allows us to get better recovery out of logs through not only being able to set better sawing patterns through the scan and set capability, but we're also using things like much narrower kerf saws, narrow cut saws, so that we produce much less sawdust out of each log.
What would you say the kinds of the main benefits that you are experiencing or will experience as you progress?
Well, firstly, it allows us to manufacture much more volume, particularly critical at the moment, given the demand situation in the market. Some of the other benefits, the contraflow kilns essentially allow us to produce a lot more wood with the same heat plant capacity. Boilers or heat plants are a very large investment, so they tend not to be the sorts of things that are upgraded particularly often. So adding or changing over to contraflow kilns rather than having batch kilns allows us to produce more timber for the same amount of energy use out of our biomass. So it's all green energy. The more energy efficient we are in terms of the heat used, the better, but also a bit more electrically efficient. So we're using a bit less electricity for each cubic metre of timber that we dry. And then up in the sawmill, again, there are benefits in terms of the electricity consumption got narrower cut saws. It's got different kind of chipper profiles. It's more highly optimized just because it's newer. So we're not only producing less waste or less residue, but we're also using less energy.
So there was a broader benefit then to the environment as a whole, as well as the benefits that brings to the business.
Yeah, that's right. We've been running a pretty strong sustainability program within Timberlink for quite a few years now. Certainly a significant outcome from the investment that we've made is that the environmental impact of each cubic metre of timber we produce is significantly reduced. So as well as those two major sawmilling assets, we're in the process of building a cross-laminated timber and glue-laminated timber plant. That's going to be at Tarpuna. That's a $60 million investment starting up in late 2023.
Just jumping in here for a second, for anybody unfamiliar with cross-laminated timber, or CLT, these are the large format timber slabs, typically used in mid-rise and high-rise buildings where traditionally you might have seen steel or concrete used. Glue-laminated timber, or GLT, or glue-lam, has two distinct markets currently. There are the stock GLT beams that you see going into houses or used over garage doors and the like. But then there's also a growing market for more complex, larger section GLT that can be used in the construction of larger timber buildings.
The investment that's been made into the cross-laminated and glue-laminated timber production facilities. So I wonder if you might be able to tell me a little bit more about that aspect.
Cross-laminated timber we see a massively increasing demand for this style of product. Moving into the future, there's not only obvious environmental benefits in locking up the sequestered carbon in the wood within the building structure for at least 50 years. It's also a lower embodied energy product than competitor materials, like there's less energy used in producing the equivalent amount of wood. We think that building technology is going to be more widespread as time goes on. It's at a very early stage, but even already people are finding that the other benefits over alternative forms of construction are getting to be pretty substantial. So looking at things like cost and logistics and safety. And for us, it enables us to add more value to the products that we're manufacturing. It allows us to better utilise the material from the log. So, for instance, we can produce more non-preferred sort of lengths in the structural wood, rather than trimming a piece of wood to a shorter length a framing type customer might like. The glue-laminated timber that's going to be used in concert with the cross-laminated timber in larger buildings. So we've got a staged approach to address both of those markets, and similar to the CLT, we see that as a growing market for us. The site, the Tarpuna site, is going to fully integrate the CLT, GLT, our traditional kind of sawmilling operation.
Is the part of the rationale for going down this route the research that's suggesting that the kind of demand for CLT and GLT is going to increase exponentially as we move forward? Is it a means of sort of putting these measures in place now so that you're able to meet the future expected demand?
Yeah, definitely. We're expecting that demand for this style of product will increase reasonably rapidly over the next few years. At the moment, there's quite a lot of imported material coming in. So there's the possibility perhaps to substitute for some of those, but more importantly to be able to supply the market as the whole market grows.
Trevor also told Sam about exciting plans to build a biocomposite plant at the Timberlink Bell Bay site. The plant will use the principles of upcycling to create a line of wood plastic composite products. More on that a bit later in the episode.
But before that, I also caught up with Daniel Wright, Director and National Business Development Manager at Australian Sustainable Hardwoods, or ASH, an advanced manufacturer and established leader amongst Australian timber suppliers, known for developing innovative hardwood products for specifiers.
We're a vertically integrated hardwood processor. We're the green mill. We process from logs to slabs. We are a timber mill. We kiln dry those slabs and process them into what most people call rough sawn timber. For us, that becomes our feedstock as the base product for our manufacturing facilities. Yep. And we've got 8 manufacturing lines where we effectively value add that timber into further processed and higher value applications.
Daniel told Sam about a range of innovations at the organisation, including what goes into the creation of its unique MassLam range of hard and softwood products using sustainably sourced GLT. The use of this range in construction has a plethora of benefits, which are great for efficiencies and keeping costs down on site, and also for the environment.
The big thing, my focus at the moment, is our MassLam line, which is massive timber construction or mass timber construction, where we're effectively delivering very large pieces of columns and beams and structural floors, which have got connections pre-attached. You're basically building an office building like a Meccano set off the back of a truck. The reason mass timber construction is growing in Australia, successful for us, but also appealing to clients and to builders, is because it's pushing in a direction that we both want to head. First of all, the construction industry is looking to pull its socks up, so to speak, and really contribute to reducing Australia's greenhouse gas emissions. So, the construction industry is responsible for, anywhere up to, depending on what paper you read, 40% of Australia's greenhouse gas emissions through embodied energy and transport and manufacture. Our delivered mass timber product is actually better than carbon neutral, polar opposite effect. So you've got builders looking to have that sort of impact, but also looking to create better outcomes for occupants. So, if you imagine a room, cold, dark, traditional kind of construction in comparison to something where the timber structure is the aesthetic, and you've got natural light coming in, it's that biophilia.
Just jumping in here for a second, if you've been a WoodChat listener from the very start, you might recall that our first ever episode focused specifically on the principles of biophilia, during which we spoke with Associate Professor Jackie Shermer of the University of Canberra, who shared her thoughts on the topic in light of research that had recently been conducted in that area at that time.
Biophilia is a strange sounding word, and you sort of hear it and you think, what are we talking about here? It's actually a pretty simple concept. So a really famous biologist, Edward O. Wilson, came up with this idea that humans need to be connected to nature for our well-being. What he did was say we are getting less connected to nature because we're spending a lot of time indoors, we're spending a lot of time in artificial environments. In the decades since he proposed that, there's been thousands of studies, and they're building a really strong body of evidence that shows if we can bring elements of nature closer to humans, the humans tend to have better well-being, and that's particularly the case for the indoor environments where we spend a lot of our time. We know that having access to natural light indoors makes a really big difference to your well-being. We also know that indoor plants make a difference, things like having a water feature inside. But then there's another area that's been proposed in the theory since the very beginning, and that is the presence of natural materials. So things like having stone products like a stone benchtop, things like having wooden surfaces. We've actually got a great bit of work that was originally done by the market research firm Pollinate. And I got involved in it because I was sent a bunch of data to review and told, well, given that you work on well-being, does this actually stack up? We think we've got some evidence here that the presence of wood in the workplace is good for well-being. So I attacked it with my analysis, and what I actually found and got really excited about was that there's a really strong association between the presence of wood and well-being. For me, I've rarely seen a data set or a study which has shown such a clear link.
So if you haven't already heard it, it might be worth scrolling back to episode 1 of WoodChat to hear the episode including Associate Professor Shermer's thoughts in full. But for now, back to my chat with Daniel.
So then you've got these types of clients and these types of builders are typically looking for, the likes of Green Building Council's 6-star or, one of these building schemes to try and show that they're doing the right thing, but creating good outcomes for the occupants. And this is why they turn to mass timber. And from our perspective, when you produce timber from a log, you get really high grade timber and you get timber with more character and more features. And successful timber production is about being able to use 100% of the log because it's responsible, but also because it makes the business cost competitive and economically successful. So making larger sections of timber, especially in some of timber species that we use, they have a really high strength to weight ratio. So that means, the cubic cost of your timber, when it's very strong and lightweight in comparison, you can produce a really efficient structure. So we're able to use the whole log really efficiently. Some of the lower grades we can hide in the middle of the timber. And so you've got the more attractive quality timber on the outside, but they're working together to create something that's cost efficient for the client, but a really good use of timber from our end.
Does that sort of speak to the smart manufacturing principle then, in terms of, from your perspective, and I suppose getting the best use out of all of the timber that you have access to?
Yeah. I mean, the whole process of Maslam is smart.
Yeah.
The other thing is, as a hardwood industry in Australia, we're being asked to transition to a plantation-based hardwood. And so there's an emerging species that we've been playing with, plantation oak. These are, some of them grown for pulp, some of them grown for timber, but in order to make that plantation base successful, the whole log needs to be used. You can't just take the best quality logs and then send the rest off to some low application. You've got to use it all.
Yeah.
That timber has different properties, different applications, and markets don't exist for all of that fiber as yet. So part of the reason we developed Maslam is with that in mind. In the future, we need to be able to put this emerging timber species, which currently doesn't have a home for all of its fiber, we had to develop markets that can take this and that are cost competitive and attractive for the supply chain. But talking about smart manufacturing, the process in Maslam is quite smart from the start. So we get heavily involved with the builders, architects and engineers.
Yep.
We've got an in-house engineering crew who offer timber specialist design support. So they work with that consortium to effectively build a 3D model. You basically build this structure in virtual reality. Every screw, every bracket, every milling, every drilling is millimeter perfect in virtual reality. We take that model to create shop drawings. Every single part has its own individual shop drawing, its own piece. We can create takeoffs for screws, so we know what to order and get well ahead of production. We send those shop drawings off to our steel fabricators so we can have those produced. We've got assembly drawings to show how they will assemble with our timber.
Daniel went on to explain that further enabling the development of the Maslam range was the company's commission of the world's largest Hundegger K2i CNC machine, bit of a mouthful there, a massive robotic timber profiling machine, essentially. And this represented the first such machine with the capabilities necessary to perform the highly effective production technique of computerized numerical control, or for short, CNC. The K2i CNC machine has more than 160 tools, including drills, routers, as well as circular and chainsaws, all of varying sizes, and of which the machine's software, known as Cambium, can automatically select to complete the desired level of profiling.
And so the Cambium software will actually look at this component and it will choose one of 160 different tools. So drillings, saws, circular saws, chainsaws, mitering, routers. And what it does is it actually selects the right tool to do all of the machining. It does this on its own. Our technicians can override that for efficiency or to produce higher quality. We've built a number of facilities on our operation out in Hayfield. On the same facility, we produce our feedstock. So it is all on the one site. The whole facility is designed to be lean. It can come from rough sawn feedstock, where it will go through and be finger joined, planed, laminated in depth, then planed again. Then those large sections that were laminated would be laminated in thickness, all in one pass. Then it goes through the world's largest spiral head planer, and that's automated. It will run through that, put arises on the corners. From there, you've got a really square, well-dressed column or a beam. They then, still continuous, will pass into one of our massive robotic CNCs, where the profiling, the milling, the drilling, the mortising, all of those actions will happen on that. And then it would come out the back end ready to go to our finishing crew, where we'll pre-attach the connections and give it a coating and a touch-up. So it's all of that happens in one pass. It's a seriously efficient and very technical. Initially, the idea was to produce larger section columns and beams, things that would be suited for the mass timber builders that were emerging in Australia at the time. But we quickly learned nobody's going to have a better understanding of our timber properties and how to produce cost efficiently than ourselves. We were doing it every day. So we started to develop that in-house design and engineering support. And that's when we started ramping up our CNC capacity. So it's been slowly growing since 2018 and it's just snowballing.
And that is presumably then, or has been, a continuous evolution which kind of takes into account or embraces emerging technologies. Is it evolving as you go, basically?
Yeah, it is. We're accumulating some high quality people as time goes on in this space. As this space evolves, there's new technology popping up to accommodate it or to make things more efficient. It's a constantly emerging space, but as this thing grows, the mass timber solutions can become more cost efficient, and we refine that process, with every single job. So yeah, it's constantly evolving. In traditional construction, you might build, say, a steel column and beam or a concrete, but then you'll employ our traditional supply chain to come in and cover that in timber to make it attractive. Whereas mass timber, it is the aesthetic, it's the structure and it's the aesthetic. And so it's honest, it's raw. What that allows from a design perspective, it allows a bit of creativity and it's exciting.
And is that something that with a product like Masslam, you've seen an increase in like that sense of collaboration with the construction industry?
Absolutely. It's been great for us because we, as the timber supply and as the vertically integrated manufacturer, the benefit of mass timber has been we've been able to have a direct dialogue with decision makers, been able to streamline that process. The supplier talking to the client direct, what's possible, what's efficient, how can we do this together? Their needs and our needs are aligned. You build it in a boardroom with the design team, with the builders, so that what happens on site, all the problems have been solved. We also have the installers on board. And then as a building is ready to construct, we will work with them to load truck in lifting sequence. This process allows us to create a 3D model of the truck. So we know which beam they want to lift first. So they might want to get all the columns in on the ground floor, then connect the beams. Then they might want to put the floors on top and then, move on to the columns above. So we know which is the first column and which is the last column, and we can load a truck with every component drawn to perfection. And so they know which one they can lift off on site. So they are building this off the back of a truck. And that's one of the reasons that makes mass timber really efficient, is because we've prefabricated everything in our factory. And then on site, all they need to do is just focus on getting this thing up. So they're 30% faster than traditional construction.
As mentioned earlier, during Sam's interview with Trevor Innes at Timberlink, the environmental outcomes being worked towards at the company's Bell Bay location with its planned biocomposite site were also discussed. As promised, here's more on that from Trevor.
One of the things that we've been looking at doing is to make better uses of our residues. Every sawmill produces residues in the form of sawdust and planer shavings and offcuts, and typically a significant proportion of that is burned in heat plants to provide kilns with the heat that they require for drying the wood, and that's that will, I think, always continue because it's a green form of energy. But most sawmills will have an excess of residues, and the markets for that are currently a bit variable. Some places it gets made into particle board and those sorts of products. So there's a range of uses, but a lot of them are typically not very kind of high value for that fibre. So what we've been looking for is a way to better value add to that fibre. We think we've found that with wood plastics composites, it's combining about 50% wood fibre with plastic, and that's a very high proportion of that plastic. I think it's over 90% is recycled high-density polyethylene. So that's all going to be sourced from within Tasmania. Really substantial increase to the amount of plastic that can be recycled and reused within Tasmania.
In terms of how the plant will be powered, I think I read somewhere that that's going to have a largely renewable aspect to it as well. Is that right?
Yeah, so we're very lucky in Tasmania that the vast majority of the electricity that's sold onto the grid here is green already, through hydro and wind farms principally. But in addition to that, we're putting solar panels on the new building that we're constructing. So we'll be able to provide a significant amount of electricity to our own site, not just within the wood plastics composite plant, but throughout the site.
And again, is the benefit there twofold? So number one, the potential additional income stream from the wood plastic composite, and then number two, the fact that that plastic is being recycled and put to use and being locked in to, say, a building or something like that for many years.
Yeah, that's right. I mean, I think most material kind of environmental benefit that you find, particularly in the private sector, tends to happen at the intersection of financial benefit and environmental benefit. But it matches our environmental goals and our environmental profile in that the plastic part of the wood plastic composite is recycled when it gets to us. The product itself can be recycled at the end of life. So we're really looking towards trying to improve circular economy kind of outcomes from the products that we're manufacturing. And this is probably we see this as a really good way to go down that path.
And just jumping in here briefly, to add that Daniel mentioned that Ash too has a commitment to and passion for the circular economy. Daniel explained to me that the company's manufacturing byproduct is currently being used to generate green energy that powers 85% of its energy needs. Plans are now afoot to work towards making that 100% by using byproducts such as sawdust and wood chips to create additional green hydrogen. Using this baseload of energy day in, day out means that Ash would become a reliable supplier of energy to its own hydrogen plant. But not only will that mean the plant itself will become entirely powered by green hydrogen, the company also plans to partner with other local businesses to provide them with a predictable daily volume in an effort to help them decarbonise too. And while this would obviously allow those companies to switch from using carbon-emitting fossil fuels to better than carbon-neutral fuels, it would also close the loop in terms of energy, because any carbon emitted during the process would be captured by Ash's regrowing forests.
It's so exciting to hear about the latest innovations in the sector when it comes to manufacturing, especially as the benefits extend way beyond the industry itself.
Absolutely. And these two companies are just the tip of the iceberg, really. There's so much innovation happening across the industry right now, and Australia really is leading the charge.
And so that's just about it for another episode of WoodChat. We hope you've enjoyed what you've heard, and please make sure to join us again next time.